The multiverse is a theoretical framework suggesting the existence of multiple universes beyond our own, each with its own laws of physics. This concept captivates scientists because it challenges our understanding of reality and offers explanations for cosmic phenomena that remain unsolved. Imagine a cosmic landscape where every possible outcome of every event occurs in a different universe, sparking endless possibilities and scientific intrigue. Modern physics defines the multiverse as a collection of potentially infinite parallel universes, each with distinct physical laws and constants. Variations of this concept include the many-worlds interpretation of quantum mechanics, which suggests every quantum event spawns a new universe, and the bubble universe theory, where each universe is a bubble in a vast cosmic foam. These ideas push the boundaries of scientific imagination, challenging our perception of space and time. Fundamental physical principles like quantum mechanics and cosmic inflation suggest the possibility of a multiverse. Quantum mechanics introduces the idea of superposition, where particles exist in multiple states simultaneously, hinting at parallel realities. Cosmic inflation, a rapid expansion of the universe after the Big Bang, could have created pocket universes, each with its own unique properties, expanding the scope of cosmic exploration. Scientific theories such as the many-worlds interpretation and string theory have significantly shaped the multiverse concept. The many-worlds interpretation posits that every quantum decision creates a new universe, while string theory suggests multiple dimensions beyond our perception, potentially housing other universes. These theories provide a mathematical framework for understanding the multiverse, offering a glimpse into the complexity of existence. The multiverse concept presents a potential solution to mysteries like the fine-tuning of the universe, where physical constants appear perfectly set for life. If multiple universes exist, it could explain why our universe seems uniquely suited for life, as we simply inhabit one of many where conditions are right. This idea challenges philosophical notions of uniqueness and purpose, prompting debates about the nature of existence. The multiverse hypothesis offers a potential solution to the cosmic conundrum of why our universe's physical constants are so finely tuned for life. By proposing an infinite array of universes, each with different constants, it suggests that our universe is just one where conditions happen to support life, thus demystifying the apparent precision. This perspective shifts the question from why to how many, suggesting that probability rather than design governs the universe's fine-tuning. The concept of a multiverse introduces profound philosophical challenges, particularly concerning the nature of reality and knowledge. If infinite universes exist, it raises questions about the uniqueness of our experiences and the validity of our observations, as they might be just one of countless possibilities. This idea challenges the epistemological foundations of science, as it suggests that some truths might be inherently unknowable or inaccessible. Theories of the multiverse, such as the many-worlds interpretation, chaotic inflation, and the holographic universe, each offer unique perspectives on the nature of reality. The many-worlds interpretation suggests every quantum event creates a new universe, while chaotic inflation posits that eternal inflation leads to a vast number of universes. The holographic universe theory proposes that our universe is a projection of information stored on a distant boundary, challenging our understanding of dimensionality. The many-worlds interpretation of quantum mechanics posits that every quantum event results in a branching of the universe, creating an infinite number of parallel worlds. This interpretation suggests that all possible outcomes of quantum events actually occur, each in its own universe, leading to a multiverse of endless possibilities. This concept challenges our understanding of reality, as it implies that every decision and event spawns a new universe, each as real as the one we perceive. Support for the many-worlds interpretation comes from its ability to explain quantum phenomena without invoking wave-function collapse, a concept that some physicists find problematic. Critics argue that it lacks empirical evidence and raises questions about the nature of reality, as it implies an infinite number of unobservable universes. Despite these challenges, the interpretation remains a compelling framework for understanding the complexity of quantum mechanics, offering a coherent explanation for the behavior of particles at the quantum level. The many-worlds interpretation suggests that every decision we make creates a new reality, leading to profound philosophical consequences. This implies that there are countless versions of ourselves living out different outcomes of our choices, challenging the notion of a singular identity. Such a perspective raises questions about free will and the meaning of our actions, as each decision branches into a new universe with its own unique history. The theory of chaotic inflation proposes that the universe underwent a rapid and exponential expansion shortly after the Big Bang, leading to the formation of bubble universes. Each bubble represents a separate universe with potentially different physical laws, created by quantum fluctuations in the early universe. This model suggests that our universe is just one of many in a vast cosmic landscape, each expanding and evolving independently. The concept of eternal expansion arises from the idea that space itself is constantly inflating, driven by a mysterious force known as dark energy. This process could continue indefinitely, creating an infinite number of bubble universes as space expands faster than light can travel. Such a scenario implies that the multiverse is a never-ending tapestry of universes, each with its own unique properties and potential for life. Quantum fluctuations are minute, random changes in energy that occur in the vacuum of space, playing a crucial role in the creation of new universes. These fluctuations can cause regions of space to undergo rapid inflation, leading to the formation of bubble universes with distinct characteristics. This process suggests that the multiverse is a dynamic and ever-changing cosmic structure, where new universes are constantly being born. The implications of chaotic inflation for our understanding of space, time, and physical constants are profound, suggesting that these elements are not universal but rather variable across different universes. This theory challenges the notion of a single, unified set of physical laws, proposing instead a multiverse where each universe has its own unique constants. Such a perspective could revolutionize our understanding of the cosmos, offering new insights into the nature of reality and the limits of scientific knowledge. The holographic principle suggests that our universe might be a projection of information stored on a distant two-dimensional surface, much like a hologram. This idea implies that the three-dimensional world we perceive could be an illusion, with the true reality existing in a higher dimensional space. If applied to the multiverse, it could mean that each universe is a unique projection, offering a new way to explore the nature of existence. Evidence for the holographic universe comes from black hole physics, where the information paradox suggests that all information about a three-dimensional object can be encoded on a two-dimensional surface. Studies of cosmic microwave background radiation have also hinted at anomalies that could be explained by a holographic model. These clues suggest that our universe might be a shadow of a more complex reality, challenging our understanding of space and time. The holographic principle could bridge the gap between quantum mechanics and gravity by providing a unified framework where both can coexist. In this model, gravity emerges from the quantum entanglement of particles on a two-dimensional surface, offering a new perspective on how these forces interact. This approach could lead to a theory of everything, reconciling the discrepancies between the two pillars of modern physics. If our world were merely an illusion, it would fundamentally alter our understanding of reality, suggesting that what we perceive is just a facade. This perspective could redefine concepts of identity and existence, as our experiences might be projections of a deeper truth. Such implications challenge the philosophical foundations of science, prompting us to question the nature of consciousness and the validity of our observations. Mathematical theories like string theory and ADS/CFT correspondence offer potential pathways to confirm or refute the holographic hypothesis. Experiments involving particle accelerators and cosmic observations could provide data to test these models, seeking evidence of holographic patterns in the universe. As technology advances, these approaches may unlock new insights into the structure of reality, offering a clearer picture of our cosmic origins. The concept of a multiverse presents significant physical and mathematical challenges, particularly in terms of testability and predictive power. One major hurdle is the lack of empirical evidence, as the multiverse is inherently unobservable from within our own universe. Additionally, the mathematical frameworks required to describe such a vast array of universes are complex and often rely on speculative theories like string theory and quantum gravity. The testability issue of the multiverse arises from its unobservable nature, as we cannot directly access or measure other universes. However, scientists explore alternative methods of proof, such as identifying astrophysical anomalies or developing experimental advancements that might indirectly support the multiverse theory. These approaches aim to provide circumstantial evidence that could bolster the multiverse hypothesis without direct observation. Certain astrophysical anomalies, such as the cold spot in the cosmic microwave background, could potentially offer indirect evidence of other universes. This anomaly might be explained by a collision with another universe, suggesting a multiverse interaction. Such phenomena challenge our understanding of cosmic history and encourage further investigation into the possibility of parallel universes. Recent experimental advancements in particle physics and cosmology might bring us closer to confirming the existence of a multiverse. Technologies like the Large Hadron Collider and gravitational wave detectors could reveal subtle clues about the nature of reality, hinting at the presence of other universes. As these technologies evolve, they may provide the breakthroughs needed to substantiate the multiverse theory. The fine-tuning of the universe's physical constants raises questions about why the laws of nature seem perfect for life. This apparent precision suggests that our universe might be one of many, each with different constants, where only a few are conducive to life. The Anthropic Principle offers an explanation, proposing that we observe these conditions simply because we exist in a universe where they allow for life's emergence. In cosmology, fine-tuning refers to the precise values of the universe's physical constants that allow for the existence of life. This precision is so unlikely that it suggests the possibility of a multiverse, where countless universes exist with varying constants, and we happen to live in one where conditions are just right. This argument challenges the notion of a single, designed universe, proposing instead that probability and chance govern the cosmos. Alternative explanations for the precision of physical constants include the idea of a self-organizing universe, where natural processes inherently lead to life-supporting conditions. Another theory suggests that unknown laws of physics might dictate these constants, making them less arbitrary than they appear. These explanations challenge the multiverse hypothesis by proposing that our universe's fine-tuning could be a result of intrinsic properties rather than random chance. The Anthropic Principle plays a crucial role in interpreting our universe's existence by suggesting that we observe the universe as it is because it supports life. This principle implies that the universe's physical constants are not random but are instead necessary for our existence, providing a selection bias in our observations. It shifts the focus from why the universe is fine-tuned to how our presence influences our understanding of cosmic conditions. The concept of a multiverse profoundly influences the foundations of quantum mechanics by suggesting that every quantum event could create a new universe. This idea challenges the traditional understanding of superposition and entanglement, as it implies that all possible outcomes occur in separate realities. Such a perspective could revolutionize our understanding of quantum gravity and the nature of non-locality, offering new insights into the fabric of reality. The multiverse hypothesis could potentially explain unsolved mysteries in quantum mechanics by suggesting that phenomena like superposition and entanglement are manifestations of interactions between parallel universes. This idea posits that what we perceive as quantum uncertainty might be the result of our universe's interference with others. Such a framework could provide a new lens through which to view the enigmatic behavior of particles, offering a unifying theory for quantum phenomena. Quantum superposition allows particles to exist in multiple states simultaneously, suggesting the possibility of parallel realities where each state is realized. This concept is exemplified by Schrödinger's cat, a thought experiment where a cat is both alive and dead until observed, hinting at a universe where all outcomes occur. Such a framework challenges our understanding of reality, proposing that every quantum event might spawn a new universe, each as real as the one we perceive. Quantum entanglement and non-locality suggest that particles can be instantaneously connected across vast distances, hinting at a deeper multiverse model. This phenomenon, famously described by Einstein as spooky action at a distance, implies that changes in one particle can affect another, regardless of the space between them. Such interactions could indicate that our universe is part of a larger interconnected system, where entangled particles communicate across different realities. The multiverse concept could aid in developing a theory of quantum gravity by providing a framework where gravity and quantum mechanics coexist. In a multiverse, each universe might have its own set of physical laws, allowing for the exploration of gravitational effects in different contexts. This approach could lead to a unified theory that reconciles the discrepancies between quantum mechanics and general relativity, offering new insights into the fabric of reality. The idea that the universe is a product of pure mathematics suggests that mathematical structures are the fundamental reality, with our universe being one of many possible outcomes. This perspective aligns with the notion that mathematical equations can describe the laws of physics governing our universe, as seen in theories like string theory. Such a view challenges the traditional understanding of existence, proposing that our universe is a mathematical construct within a vast multiverse. The Platonism hypothesis posits that mathematical forms exist independently of the physical world, potentially explaining the existence of a multiverse. According to this view, each universe is a manifestation of a different mathematical structure, with our universe being one of many. This idea suggests that the multiverse is a realm of possibilities, where each universe is governed by its own set of mathematical laws, offering a new perspective on the nature of reality. In the realm of higher dimensional spaces, the multiverse concept finds a mathematical playground where extra dimensions could house entire universes. These dimensions, beyond our familiar three, allow for complex interactions and unique physical laws that might govern other universes. Theoretical models like string theory propose up to 11 dimensions, suggesting that our universe is just a slice of a much larger cosmic structure. The exploration of alternative geometries opens the door to universes with radically different properties, where the rules of space and time might not apply as we know them. Imagine a universe where the angles of a triangle don't add up to 180 degrees, or where parallel lines converge, creating a non-Euclidean landscape. Such geometries challenge our understanding of reality, suggesting that the multiverse could be a tapestry of diverse and exotic worlds. Within string theory, The idea of a multiverse emerges naturally from the concept of vibrating strings that form the fundamental particles of the universe. These strings can vibrate in multiple dimensions, potentially creating a vast array of parallel universes with different physical constants. The theory suggests that our universe is just one of many, each a unique vibrational pattern in the cosmic symphony. A unified theory of the multiverse would elegantly combine the principles of quantum mechanics and general relativity into a single framework. This theory would describe how different universes interact, possibly through quantum entanglement or gravitational effects, offering a comprehensive view of the cosmic landscape. Such a theory could revolutionize our understanding of reality, providing a mathematical blueprint for the multiverse. The confirmation of a multiverse would profoundly alter our worldview, challenging the notion of a singular reality and reshaping our understanding of identity and existence. It would suggest that our universe is just one of many, each with its own unique history and potential for life, prompting a reevaluation of philosophical and spiritual beliefs. This paradigm shift could lead to new insights into the nature of consciousness and our place in the cosmos. The identity problem in a multiverse suggests that there could be infinite versions of ourselves, each living out different possibilities in parallel universes. This raises profound questions about the nature of self and whether our identity is unique or just one of countless variations. Imagine a reality where every decision you make creates a new version of you, each with its own distinct path and experiences. In a multiverse, the concept of copies of ourselves implies that every possible outcome of our lives is realized in parallel worlds. This means there could be countless versions of you, each experiencing different life events based on the choices you make. For example, in one universe, you might be a famous artist, while in another, you could be a scientist, each version living out a unique narrative. The existence of multiple identities in a multiverse raises significant ethical consequences, challenging our understanding of morality and responsibility. If every possible version of ourselves exists, it questions the meaning of actions and whether we are accountable for choices made in other realities. This perspective could lead to a reevaluation of ethical frameworks, as it suggests that our actions might have implications beyond our own universe. The concept of free will becomes complex in a multiverse where every possible decision is realized somewhere, suggesting that all choices are predetermined. This challenges the traditional notion of free will, as it implies that every action is just one of many inevitable outcomes. Such a view could redefine our understanding of autonomy, as it suggests that our perceived choices are merely part of a larger cosmic tapestry. The idea of a multiverse could profoundly impact religion and spirituality, raising questions about the role of a divine creator in a universe with infinite variations. If every possible universe exists, it might suggest that God's role is less about creating a singular reality and more about overseeing a vast cosmic ensemble. This perspective could lead to new theological interpretations, as it challenges traditional views of divine purpose and the uniqueness of our universe. The existence of infinite universes could radically alter theological perspectives, suggesting that divine intervention might not be unique to our universe. This idea challenges the notion of a singular creation event, proposing instead that a divine presence could be responsible for a multiverse of possibilities. Such a perspective could lead to new interpretations of spiritual texts, as it implies that divine influence extends across countless realities. The multiverse concept offers an alternative interpretation to divine creation by suggesting that the universe's existence is a result of natural processes rather than a singular divine act. This perspective aligns with the idea that physical laws and random chance could lead to the formation of multiple universes, each with its own unique properties. Such a view challenges traditional religious beliefs, proposing that the multiverse is a self-organizing system rather than a product of divine will. Historical movements like Hinduism and Buddhism have long postulated the existence of multiple realms or planes of existence, akin to a multiverse. These spiritual traditions describe a cosmos filled with innumerable worlds, each governed by its own laws and inhabited by different beings. Such ancient beliefs resonate with modern multiverse theories, suggesting that the idea of multiple universes has deep philosophical roots. The possibility of traveling between universes remains a tantalizing yet speculative idea. With current technology far from achieving such a feat, theoretical models suggest that wormholes or quantum tunnels could serve as bridges between universes. But these concepts require exotic matter and energy levels beyond our current capabilities. Despite these challenges, the idea of interuniversal travel continues to inspire scientific exploration and imaginative storytelling. Theoretical models for traveling between universes often involve concepts like wormholes, which are hypothetical passages through space-time that could connect distant points. Another model involves quantum tunneling, where particles might traverse barriers that seem insurmountable, hinting at the possibility of crossing into other universes. These ideas, while speculative, provide a framework for imagining how interuniversal travel might one day be possible, sparking both scientific and philosophical debates. To enable interuniversal travel, we must overcome formidable physical barriers such as the immense energy requirements and the need for stability in traversing different dimensions. Theoretical constructs like wormholes suggest potential pathways, but they require exotic matter to maintain open passages, a substance not yet discovered. Additionally, the sheer distances between universes, potentially spanning billions of light-years, present a significant challenge to current technological capabilities. Wormholes and quantum tunnels could serve as bridges between parallel worlds by creating shortcuts through space-time, theoretically allowing for instantaneous travel. These structures, predicted by Einstein's theory of general relativity, would require exotic matter to stabilize their passageways, preventing collapse. If harnessed, they could revolutionize our understanding of cosmic connectivity, offering a glimpse into the vast multiverse beyond our universe. Hypothetical exotic matter with negative energy density could play a crucial role in stabilizing wormholes and enabling interuniversal travel. This matter, unlike anything currently known, would counteract the gravitational forces that threaten to close these cosmic passages. Its existence remains speculative, but if discovered, it could unlock the potential for exploring parallel universes, transforming our approach to cosmic exploration. Future developments in quantum physics, artificial intelligence, and astrophysical observations could revolutionize our view of the multiverse by providing new insights and technological advancements. Quantum physics might reveal deeper connections between universes, while AI could process vast amounts of data to identify patterns indicative of a multiverse. Astrophysical observations, such as detecting cosmic anomalies, could offer empirical evidence supporting the existence of multiple universes. Advances in quantum physics could hold the key to unlocking the mysteries of the multiverse by providing a deeper understanding of superposition and entanglement. New experiments with quantum computers and mathematical models might reveal how quantum phenomena manifest across different universes. These breakthroughs could lead to a unified theory that explains the interconnectedness of all realities, offering profound insights into the nature of existence. New experiments in quantum mechanics could provide direct evidence of a multiverse by exploring the phenomenon of quantum entanglement on a cosmic scale.